Nope, that's not what I wanted to do. Hello, how are you all doing today? I forgot that I don't have this thing on my stream deck and I went to Mac main. And that's not what I want. I want to go to this, but turn on the camera. That's what I wanted to do. How are you all doing today? Happy Wednesday. Halfway through the week, we can turn that off. So let's see. We have, today is more Shenzhen I day. We are outsourcing ourselves to Shenzhen for more electrical engineering puzzles. And as normal, we ended the last Wednesday's stream with a failing to beat a puzzle. And now it's like, okay, time to try this again. I also do want to move my camera closer. Camera? No, phone. Because I'm expecting some people to contact me, and I need that here so I can answer it. All right, so that will just sit right there for me. Now, let's see, a couple different things. Let's see. Let's see. Actually, I don't know. I don't have any other things right now. No news yet. Maybe soon. Okay, so where we left off was this control router important, which is a simple data router for smart grids. And this one was, like many of them, breaking my brain because the idea here, and maybe we should just start over with this. We have data coming in, and then we have obviously data coming out. We have this thing which gives us the local ID number. And so we have to check, we have to do basically like a binary sort where if higher in comes in, it was coming from something higher than us. And we have to check, is it still higher than us? If it is, send it to higher out. And I guess we can look at verification. So like higher in, for example, 573, that should go to lower out. This goes to meter out. A higher in never goes to higher out, which is interesting. Meter in does go to lower out, higher out, and meter out. Okay, so that makes sense. It goes to, like, that can go to anything. And then lower in goes to meter out and higher out. So I suppose we could try to, I wonder if we could play with that a little bit. Now, I don't believe that it's accurate. Like in a real world situation, I would probably want to like check, because if it's higher, it could still be higher, right? And maybe we'll fall to that in like future, like after this this page, there's like 10 pages of tests or something like that. I don't know how many tests there are. But we end up having this this thing come in that is a packet that comes in that is going to be the ID, and then we check that, and then we have to send it to something that tests to see, okay, well, where should you go? And then that heads out here. And the previous design that we have, basically I combined oh, that's what I did. I combined all the meters in, which works, into a single thing. And that goes into this one. Okay, so that actually, yeah, this is not too bad. That comes into here, and then I can figure out what you are. And then we have to send you to the appropriate place, but that's where we're running into trouble. Now I was trying to use this memory, and somebody I'm sort of lurking on the Zachtronics Discord. Well, the unofficial Zachtronics Discord, I suppose. And they mentioned a really interesting idea, which is don't ever reset the memory. Like never send like 0 out to the A0. Which is this, is X3. It's like never reset it. Because it's the same amount of information every time. If I read the same amount of information, I'll keep up. And therefore that just saves me a line of code. I can just throw in the data because we always start at the zeros. For writing and reading, which is perfect. Oh, and the other thing I was running into was space, wasn't it? Yeah, so okay, if I send this here, we did not put everything in, which we probably should have. Stacking, hello, how are you doing today? You get your weekly dose of Chad or whatever his name is. Chuck? Yeah, I don't remember anymore. But yeah, we're not working on one of his puzzles right now, though, of course. Do you remember this puzzle? Did you, how was this one? I'm getting to that point where like every time I do one of these puzzles, I either like solve it really quickly or like it takes me half a day to solve. Or more. So I kind of feel that what I want to do is just no matter what, capture this and just send it in here, which I think I can do with a smaller one. So yeah, this is where I want to go with a new design. So let's say I start with you. I mean, I can even go up there. And let's say we have some memory. I might be able to get away with putting this here. Nope, nope, not escape. Ooh, but no, I need this to be one out a little bit. So I can do things like that. With, of course, the problem being that I've lost... Oh, but I don't need the A. I don't need the A. So I could just do that. Okay, now I still have X3 and X2 to send messages to something else. This one isn't ringing a bell, but it has been over a year since your last playthrough. Oh, have you played through this multiple times? That would definitely make things easier probably to like play it through and then come in later on and see how it feels. Okay, you think you did it twice. Nice. All right, so let's say we wait for a message to come in on any one of these, and we just throw it in here, and that's all I really care about. So if I were to do that, we want to SLX on X1. We can move the first one into ACC. So move X1 to ACC, move ACC to X0. And then I just want to repeat this for how many times, right? It's like 1, 2, 3, 4, 5 more times. So move X1 to X0. And then we just go back to here. Oh, and then I need to send a message out to something to let it know we're good and ready to go, which probably will have to now be another small one like this. So that'll be move, we can just move ACC to X3 to let it know, time to go. It's your turn. I could try to put this down here. Like that, just to give myself a little bit more room. Okay, so if I do that, we should see this pop up with ACC after everything's been written into here. There. Okay, so we have all of you. You're into there, and then we have the 596 in here too. Perfect. Epic, hello. How are you doing today? I've been watching you play this for a fair amount. I really want to play it myself, but I know how addicted I would get, so I'm doing my best to stay away from it. If you want to play it through me, where you just help me figure out the puzzles, I would not mind with that. And then when I'm done, we're done, right? Once in Blue Moon, I need to scratch that electrical engineering itch, since it's too much effort to scratch it in IRL. I do want to try some electrical engineering stuff in real life, although I don't know how much of it would actually be considered electrical engineering besides just like an IoT breadboard and some like wires and other little chips and fun things. Like I want to try some IoT stuff eventually. And I've done like a really tiny amount in the past. So that could be a lot of fun. You did promise your wife a project many years ago, so one day you guess you need to scratch it IRL. Well, yeah, that's sort of like me. I have like a whole bunch of projects which I think could be actually like useful and good and interesting, but I just never get around to them. Like everything else, right? We have the infinite backlog. Okay, so we grab you, and we now know that it's time to go, right? Like everything has been saved in here, and we can go. And though I need to... So if I compare you... So test greater than... Okay, so if ACC is greater than X1, we need to go to the higher one. So I wonder if... I only need 2 X's. If I use a... No, because this needs to be... It would need to be something like this, and that... might actually be okay, except for the fact that the P isn't reading, is it? Or is it? say I throw you out there. Then, and then we're gonna run into cable problems. Yeah. Our house has all of them new 1000 watt LED lights, so turning on the light to the bathroom at night is pure pain. So I did promise to hook up red LEDs around the baseboard and hook up a light sensor to turn them on when the lights are off. Oh, nice. Yeah. I know somebody who has smartified, IoT'd. What's the appropriate word for that? All of like their house. Hey, Sophie, you want to hang out? It's okay, Zoe. You can hang out here and take my arm up. It's okay. All right, so yeah, so this is the same problem that we had before, which means that I don't think that I can do this. But if it's an X bus, I can share that with everything else. So this tool wouldn't work, but maybe I can just do the same trick we do with the ends and send that on out. Yeah, so what if instead of this, we continue to have you? Like we could do something like that, and then I just want one thing coming out here. And I just do that. The problem, of course, being that, okay, so then you can all be X's. And I can make you go behind the scenes, so I can do. That's the wrong one. So I can make you do that. You can still have the X2 like that. And now for reading from memory, I want just the Ds. So we do a lot of combinations like this. I don't know if that's gonna work, but we're certainly gonna try it. Okay, you got the idea for the baseboard lights from Ben Heck. He was a cool electrical engineer that came up with the cool little fun projects you can do around the house. Nice. Yeah, I think I learned that from, we had this person who was an electrical engineer, and she came into our, we had her come in every year for guest lectures to the students. And she was arguably one of the best guest lecturers because the projects that she had were just so amazing. And so I think she convinced like always several students to do IoT projects and like what you can do with code and like why learning code is important, which is really cool. Okay, so if I get this, I want to send, okay, so what if I just send, okay, so we're gonna move, let's just say like 1, 2, and 3, right? So if I want the first one, we just send move 1 to x2. If ACC is less than that, I want to move lower out, so that's going to be 3 x2. And then equal is going to be okay, equal is going to be 0, right? So, oh no, move 2 to x2. And then no matter what, we're going to move ACC to x2. And then we reset, okay, this might work. So then it's always on the x3s. We're going to wait until we get something here. Let's move. We'll move it to ACC. So move x3 to ACC. I want to see test equal ACC to 1. I guess like test oh, we could just do this. Test equal to ACC 1. And now we do the thing, right? So when we do the thing, I just want to move everything out to here, and it's going to be 6 things. So move 6 to ACC. I want to label this so yeah, I don't actually need the move ACC2, do I? Because I know which one this is. So I don't need that at all. I just need to move this in ACC, test to see if it's equal to that, move 6 to ACC. Then I want to sub, then I want to loop through. Can I do not equal? Oh, test equal to ACC1, and I can just do jump to start back to here. I don't need the pluses for everything anymore. Move 6 to ACC. I want to have my loop label, and I just want to move x0 to x2, sub 1. Test equal ACC and 0. If you are that, jump to start, we're done. Otherwise, jump back to loop. Oh no. What can I do to save some space? Like, I'm off, but I have one line. Okay, yeah, I can remove the jump to start if I just put everything on pluses, right? Oh, and that should be a minus anyways. Like if you're not equal to 1, jump to back here. Okay, so move. Okay, so sleep on X3, move that to ACC. Test if you're equal to 1 to make sure it's me that I'm supposed to do. If you're not equal to 1, jump to start. The move 6 to ACC sucks because this is where it's like, okay, I need to go through 6 times, right? I have 5 lines, so I don't think I can move this out anyways. Ooh, but I have 6 lines if I wait. 1, 2, 3, 4, 5, 6 lines? Okay. What if we just do this? Test equal to, and then I just want to move this out 5 times, right? So move X0, X2. And I just literally copy this. Three, 4, 5, 6 times. You're doing testing if you're equal to 2. And you're testing if you're equal to 3. And that's it. Like, would this work? No. Why? Okay, we send all of you out there. 596 gets sent to you. We test, okay, are you greater than this? We're equal, right? So this is gonna go meter out. Test less than, not test equal. Okay, move that out, so move 2. Why are, interesting, okay. Because you're that got read into memory here, and then you're still trying to read in. Oh, that's too bad. Yeah, that's unfortunate. How does this work? Should I send a null immediately afterwards? Should I like move null to X2? No, because okay, I need to sleep. So can I do a loop? Can I do a loop here in less lines than it takes this? So it would be move 6 to ACC. Loop. Sub 1. Move X0 to X2. Test if equal ACC 0. If equal to that, jump to start. No. If not equal to that, jump to loop. End. Sleep 1. Okay, so move x3 to ACC, test if equal to ACC x1, or just 1, sorry. Move 6 to ACC, which that's the rough part. Loop sub 1, move x2, okay, so move it out. Test if we're equal to 0. If we're not equal to 0, jump back to the loop. Okay, so the problem is I need to somehow get to the end here. I don't think I can jump backwards by a certain amount of lines, right? Which would be nice. Like if we could just say like, hey, JR, like, you know, JRO or -6, -4. Unless, of course, I'm wrong with the timing of this, and I can get away with one, it's actually one less. It's like, I wonder if I would just want like a sleep 1 at the end here. So if I do that, let's see, you're 1, 2, 3. Ooh, you still went to sleep. You still read on that. And wait, the first one's lower end. Why are you on sleep? Okay, so all those get written in there. We send a 2 out. Okay, you all wake up. We move you in. Interesting that none of these ACCs update. That's also really interesting to me. Only one of them can move this in. That's what I'm seeing, right? Which kind of sucks. Doing dynamic ports would be nice too if I could like save the port that I wanted to send out into like a variable, but I can't do that. That's too programming. Like I feel like I'm a lot closer than we ended up last time, but I don't feel like I'm actually still, like I still feel like there's this major hurdle to get over. I don't know if I don't know. I thought the sleep one would help here. Maybe I don't put the sleep one there. Maybe I put the sleep one here. I don't even need this start, do I? So if I just sleep one and then we sleep X on there. Oh, but it still, yeah, it still has the same problem where it's waiting at a normal amount of time. I could cheat and have the other one sleep more. What if I say, okay, you're gonna sleep everything but lower end sleeps 1, like 2. Here, you could just sleep 3. Interesting. Okay. The move null doesn't work. Why did you get 4 out? I just moved the problem around. This is a terrible idea. Okay, so the problem is that we get to, you're trying to read on the same trace. What if I just send to the first one, right? So like X2, you go to X1 like this. So let's reset these. And we say, okay, sleep X on X1. Let's see. Drago! Hello, welcome. Thank you so much for the raid. How are you doing today and how's your stream? Wee! Yeah! So we're playing Shenzhen I today, which is an electrical engineering puzzle games from Zachtronics, which is a game studio that made a lot of programming or programming adjacent games, like very logic-based puzzles, very like break your brain type puzzles too, which they're all really good. We've played TAS 100 previously to this, and we are currently breaking our brains on here. I have no idea how far through the entire game we are. We've been playing through this for a couple weeks though. We only do it one day per week though. And right now the puzzle that we're on is we get some inputs through here. So we have basically a series of numbers all come in at one time, so during one tick. That's either higher, exactly equal, or lower end. So basically think a binary search tree. And then we have to deal with this information coming in and then send the exact same thing out, but either higher than us, lower than us, or equal to us, depending upon what it is. So currently I grab all this information in, and the only thing I'm really doing is I'm just stuffing it into memory here. Then I'm calling this chip here and saying, okay, I've stuffed everything into memory, do the next thing. And it then checks to see, okay, what's higher or lower. If I don't have this step and we just go straight to lower out, I wonder if that would work. So here, let's reset this a bit. So if I use a large chip here, you still have to come in through there. You can still come in through there. Okay, so if I move X0 to ACC, I want to test to see if you are let's say this is gonna do lower out. I want to test to see if you're lower, right? So test less than ACC X1. If you're not less than that, we're gonna go to this one here. So let's I have to do that. Am I gonna have... I don't have the room for the traces for this one because I need to get access to you. So that's not gonna work. So I don't think I can do big ones. I was like, okay, you're gonna have to come out like this. I could do that. That grabs the X3. But now you're gonna have to... You could do that though. But I'm out of exports, which means this exit now needs to be like that. Like I'm sending to out and to here. No, that's not gonna work. But I don't have any more exports. I could have another export if I save this one and I throw you in. I'm losing this export here. So if I put you there, oh, but I don't have enough room to throw you in here and all of you in here. I need the big one for that, just to have more coding space. Now I am moving this out this many times. Okay, so I'm moving this to X0 only to move that down, but what if I don't do that? What if I just say another... Okay, what if I start with this? We move X3 to X0, and then we just repeat the X1 again. X1 to X0. If we do that, we grab you, we have 5, 9. Oh, I did not get that out. I don't move you to X1. There we go. We get the 5, 9, 6. Okay, cool. So 596, which is this one, and then 596, which is the first message, in this case from lower in. Okay, so I can test those things, right? And it's 1, 2, 3, 4, 5, 6, 7 now. I need to test to see this won't work the way I want it to. Because now I'm trying to get to D1. I'm gonna block this port. I can't go like diagonal here. I don't want to connect to self. So we're back to the electro engineering. It's like the tracing and layout problem. If I did this small one, it's the same number of ports, but it is more room for us. So if I need to then send out like, okay, we're done, head out to X2. So and then we're out, we're done. I could even potentially move you down here. That way I have this. Now I could use a bridge to get access to X0 again. Although I lose it here, because I can't get a sideways bridge. I could potentially just go like that. Because I don't care about the A. Maybe? I might actually care about the A now. But I can't really, can I? Yeah, so so I think I need to go back to just sending out the first one down and not sending you out. So I need to send X3 to X2. So send this out first. Meanwhile, you're all saved in here. Oh, I wonder if I want to send both of them out. Oh, but now I can't do both. Right, which kind of sucks. It's like the same problem over and over again. I'm just moving the problem around. Okay, so let's say we do reset this every single time. So in that case, I just move X1 to ACC, move X1 to X0. So we move X3 to X0. Move X1 to X0. So okay, this one, all the way there, and then just move so 1, 2, 3, 4, 5, 6, which is that. I don't think I can do this. I think I have to move 0. Oh, but then we lost the A0 because I don't have enough ports. So it's like like a bigger chip won't help because this is the maximum amount of X ports that I can get. Okay, so can I turn this into a loop to just move this out in less lines than this is here? So I want, this is 6, so I want to move 6 to ACC. We start a loop, and then we move X1 x0. We sub 1. We test if equal ACC 0. If you are equal to 0, okay, if we're not equal to 0, we jump to loop. Otherwise, we're at the end now. We don't need you anymore, so we've gained you. Okay, so if we do that, I can... All right, so we gained what, 3 lines? I want to try either moving this into here. Well, I guess like first, let's see if this works, right? Yeah, so 1, 2, 3, 4, 5, 6. So all the way to 17. Perfect, okay. So at the end of the loop, I could send you out to here. Okay? Let's move x3 to x2. And then that would be it, right? So now you're gonna get now you get the 596, and we can start trying to read from here. Ooh, could I do that? Where we're both reading from this? That might work. Okay, so move that. I need to move 6 to ACC. I could move both of them out. So let's say I move x1 to ACC first, move ACC to x2, and then we do the rest of the stuff, right? So if I move x2 to ACC, I'm going to get this one first and then another one. So move x2 to ACC, test equal ACC x1 to see, okay, if the next thing that we get is equal to that. If you're not equal to that, jump to end. No, jump to next. Next is going to have to be giving someone else, like passing it along to the next one. Or we say, okay, here, it's your job now. It's your job now. You can come here like that. Okay, so wait on x0. Move x0 to ACC, test if equal to, okay, test if ACC is equal to x1. If not, jump to next. Next would be, then I want to just move ACC. I need to move everything through. That's the problem. If I'm sending two things through, that's gonna be an issue. Okay, so let's reset and have this always go to A0, right? So sleep 1. As soon as we reach 1, I want to move 0. So we have to use, which like then we get to like this not being great either. So then we reset the trace again. So if I need to go in like that, and I need the X0 to go in through here. Because I also need that, so then everything needs to be slide over by 1. But now I can't read these in. I do like the idea of not having to set the read, like the start marker, in the memory, because I think that's the key to saving trace space. Because like tracing and space on a board is like the bigger concern right now than running out of code. Although we do run out of code quite a bit too. So I don't think I want to do anything with that. I think I want to just go like that. You go out like that. I could go back to having this down here. Okay, so wait on X0. I then move 6 things into memory. So we start a loop, so move 6 to ACC, move X1 to move X0, X1, sub 1, test equal ACC 0, jump to loop. Okay, and then I need to read to this, so that's going to be this one. I also need to read to this, which might be that one. So move that to X3. Oh, I don't need to move X3 to X3. I just need to move to tell you that we're done, right? So like move 1 to X3. We're gonna have sleep X on X0. When we wake up, so therein lies the next problem, which is, what do I do if it's not lower? Oh, that's why I was sending them out twice. Okay, that makes sense. Like I could, yeah. This is where I was like, okay, what if I just send? What if we move 5 to ACC? No, I like the 6 to ACC, but like if we move X0 to ACC first. Oh, this would be 5 then. Because I've lost it from here. And then I need to move ACC to X3. Okay, so I'm going back around to like pretty much what we had at the beginning, which is I then test equal and figure out which one you're going to do and send a message out, essentially. Or I don't know. Test if equal. Okay, let's do the lower out, meter out. So test equal. So test equal ACC with X1, let's say. I want to move equals, let's say that's 0 to X2. And you go out here. This goes back to sleep. Sleep X, X1, move X1 to ACC. Okay, so you... Oh, I waited too long. Oh, I did it too quickly. Therein line being the problem. What if I have multiple chips listening to higher in the inputs? That's an interesting idea. It's like, what if I were to do something like this? Throw and your only job is to throw this into memory, right? And then we just move this 6 times. So we move 6 to ACC. We start our loop. Sub 1. Move X1 to X0. Nestive equal ACC to 0. If you're not equal 0, jump to loop. Otherwise, we're done and we go back to sleeping. So this works, right? So we're going to drop U1. Yes, then you're all in there. I have another one that sits here. Takes you in. So X on X0. Move. I probably want you over here. Move X0 to ACC. Oh, do I have to move it? Can I just test it? So maybe it's a good idea. Move you there to XAC. To ACC. I want to test if equal ACC to X1. If you're equal, send a message out. So like move 1 meter out. So that would be, let's say 0 to X2. Okay, when oh, but look at this. It only got the 4, so this one got the first one. And this one got the second one. We gets the other ones. It's like 4, 81, 70, 62, 17. Oh, fascinating. So I lose the actual value. So I need both, right? I need to send 0 out to X2, and then no matter what, we need to move ACC to X2. So we can see both of them out here. Yeah, you're waiting for a part to be written. Now we could try something like this, but then I lose that other number, which kind of sucks. I could write back to here. And then add it in at the end. That's certainly a possibility. Oh, but it's gonna be in the middle of it because we have to wait for this to be done. Okay, so I send the 2 numbers out. So then we grab you. You're gonna need to read from here if you're a lower out. You're not going to be a lower out to begin with. You're going to be a, I guess like the first one is going to skip, right? So SLX on X1, move X1. Okay, so I have to test to see equal. So like test if equal to X1, and let's do -1 for lower out. if you're not equal to that, I need to move this on up like this to like here. And we're probably going to do that to read. Or that. That looks better. We might have something like this too. Oh, I can't do that a second time. I don't want to continue the trace like that. So, you jump like that. You have to go like that. Okay. So it's not going to be exactly the same code. Okay, so test to see if you're equal to -1. If you are not equal to -1, I just want to send you out along with the next thing. So I want to move twice. So move x1 to x2. Move x1 to x2. Otherwise, we are the correct one, and now we want to move six, 5 to ACC. I guess the first thing to do is we move x1 to x2. Sorry, x3. Move 5 to ACC. We have our loop. I want to move sub 1. I want to move x0, x3. Test if equal. Okay. I think the first idea that we had was right, which is like sending it to everything. Because I don't think I have room to forward this along to another port. So instead, when I'm sending it out here, I need you to go through all the chips. You're gonna go out like this. And I guess you could still come out like that. To be consistent, I could remove you. Okay, everything comes in on there. And the X 0, I just do that. Okay. So you're gonna find everything in here. So sleep until x1 has something. Move x1 to ACC. Want to test if equal. I wonder if I do need to do that. I think I can just test if equal x1 is -1 for 0 out, for lower out. And if you're not, jump to end, but I don't have to put that at all. I could just do a positive. No, except the loops won't be happy with this. So I want to jump to start again. Okay, so if we get to here, I want to move x1 to x3, move 5 to ACC, loop, sub 1, move x0 to x3, test if equal, ACC is 0, and if you are not, jump to loop. If we take you and throw you in all of these, except you're going to be 0 for meter out, and you're going to be 1 for this. Okay, so test if equal to that, move 0. Test if equal to ACC, test greater than ACC x1. Greater than, move 1 out, so move 1. X2. Test less than ACC x1. -1. x1. x2. It's not working because I need to move it into ACC first before I can test equal, right? This part, okay, so you're moving 0 to x2. Oh. Yeah, that... Okay, you're attempting to move x1, okay, to x0. To store in here. Huh, you're blocked on read. You're not reading? Okay, so how about you? What are you up to? Why are you the only one? Okay, so wait for that. Oh, because it's the first one that got it. Because only one of them are able to read it. That's the other thing, is like, okay. The shared, I don't think the shared bus is working for this. I can do the shared bus for reading, but I can't do the shared bus for writing to something, because one thing catches it and then that's it. It's over. Okay, so if I send out if I throw everything into here. Oop, nope. Didn't want to go all the way out. New design. As soon as I get something, we move 6 to ACC. Start our loop. And then we start over. Okay, so we're done. So then I have to send a message out to X0 that we're done, right? So and then we're done. So then you come out like this. Oh, that won't work because, let's see, how'd I get... Okay, so then you sit here. Okay, so I've got all the things in here. And we've sent out, and you're waiting for me to receive, like, hey, we're done, we're good to go. I want to now calculate which one is higher and potentially send something out like this. Which will activate one of these ports. Okay, so I don't actually care about this. So I just move. I do kind of care about this. I need to know which one it is, so we have to move. Move 5 there, and then we move ACC. Okay, now I'm gonna get ACC, so move X0 to ACC. Test if, okay. Oh, ad break just started. I am going to take this as an excuse to go walk around the house a little bit and see if like that jogs my brain or something. So I will be back in a couple of minutes. We'll see if Zilby takes the chair too. So see you in a few. Oh wow, Zilby did not take the chair. Nice. That's so nice of him. He's probably still waiting for me to finish the puzzle. Alright, let's switch back to Shenzhen, and we're good to go. Okay, so I move you to ACC, which is supposedly this thing right here, right? So if we wait, why didn't I get 596 into ACC? Why are you 0? Oh, you're 0 because I lost you. That's why. Oh, that sucks. Because the initial thought is I don't want to read from memory unless it's the one I want to go for. But I have lost that one unless I use a big chip for this one here. Because that has actual like memory. I don't think I can send, because I don't have enough room to send 0 out here, although I could. Okay, so let's say we go back to just sending like 100 out to mark that we're done. So I don't need to send you to ACC. I don't need to have you do this. I just sleep into that. We move 6 things into here, and then I just move it out. So that means the very first thing we have to do as soon as we wake up let's also move 0 to you, x3, to reset you to the beginning here of memory, which I was hoping to not have to do, but now when you hit, I need to, can I jump over this? I can't jump over this. Oh, okay. And I'm out of ports because I can't read now. Yeah, I only have one for write and read. It's not like I can do another thing here. I need bigger chips. As in with more ports on it. Now it's not the code, it's the ports. Okay, I think I'm just running in circles with this one over and over and over again, which is not really working for me. So let's see if I can get the next let's skip this one and try the next puzzle, because we're not figuring that one out. So oh yeah, it's your favorite stacking. Okay, so from David, you have the Pocket I Ching Oracle. Have you noticed the I Ching, sometimes known in the West as the Book of Changes, experiencing a resurgence in popularity lately? For the benefit of those out of the loop, let me briefly explain. A hexagram is a set of 6 lines where each line is either solid or broken, with a total of 64 possible combinations. There's obviously much more to it, but I don't want to go into it too deeply. I've been studying the system for a while now, but I wish there was a quicker way to generate hexagrams. I thought perhaps this ancient divination method be brought into the modern era somehow as a pocket device. So then, of course, Carl, our favorite, says, 6 coin flips, is it then? Not at all. There is a much more detailed process through which one arrives at the reading involving yarrow stalks. I stopped by to try to describe it to you, but you weren't at your desk. Suffice it to say that we will need to generate the readings in a proper way if it is to be taken seriously as a divination tool. I found a part that works for this. It implements the physical yarrow stalk method in miniature mems. Strange. So we can just create the display for the result. Obviously, interpretation is up to the user. Oh, okay. They actually did find a chip for this. Okay, cool. Button and Oracle are simple inputs connected to a MEMS-based Oracle engine. Button? I don't see a button. Yo, is this a button? Display is a display output corresponding to a custom LCD screen designed to visualize I Ching hexagrams. When the button is pushed, the Oracle engine will generate 6 values corresponding to the 6 lines of an I Ching hexagram from bottom to top. When the final value is generated, the display should be updated to match. Okay. From bottom to top, so we gotta send, okay. Interesting. I wonder what this looks like. So interesting. I see that 100 coming out here. I don't really get what this is trying to do. Yeah, it's a button. You can see the switch to open and close. Yeah, I see that. I see this coming out and like generating stuff. I'm not really sure I understand the pattern of like displaying these. Because as far as I can tell, it's just 100 coming out. Right, is that how that works? That's so you're, oh, you're, okay, let's just try this. So we want to Anquitil, hello, how are you doing today? P1 to ACC. If ACC, no, test if equal, ACC 100. If you're equal to that, I want to take, at the same time, move P0 to dat. Let's just do this so I can watch this. Just gonna throw this in there a whole bunch of times. It's probably not generating that many values, but oh, I need to sleep in there. Okay, so we got 100 in here. So we test, okay, so we're 100. Because you're P0, I have to sleep after each one. Yeah, I guess I just don't understand. Oh, so we're delayed. We're delayed. So it starts on the off position like this. We get the button, and then I get 1, 2, 3, 4, 5, 6 inputs like this. And all that's really going on here is these. Okay. I think I get that now. Now, more importantly, how does this thing work? So if I just move like 100 to P1, sleep 1. That puts, okay, that puts you there? Oh. So if I want to turn all of them on, I have to move, let's see, 111 essentially. X3, move 111 to X2, sleep 1. They're all on. Okay. If I want like every other one on, so this is what, 100. So they 1, 0, 1, 1, 0, 1, I think. Close. 10. Like that. Okay. Okay, I think I'm understanding how this one works. And so they're going to give us pulses. And okay, so as soon as the button turns on, I now know to read 6 times. So it's going to be 6 sleeps. I can move you around at least. Now you're peas, so that's fine. I would have to do something like this, or maybe even figure out like the lower one too. Okay, so first off, we have to wait until the button is pressed, and I wonder if I should have 2 chips for this. So then tell the other one, start listening. So if we move P1 to ACC, test if equal. Oh, what if I do the other way? Can I just test? So test if equal P1 is 100. If you're not that, jump to end. End is gonna have a sleep 1. And then we jump back to the beginning again. Okay. So now we know to go here. So if we're not ending, I want to start reading in symbols from this. It's from the bottom out, right? So if you're on, so we're going to now move P0 to DAT. P0 to ACC. I need to test to see if it's on. So test if equal ACC 100. If you're on, this is from the bottom, right? So you're a 1, 10, 100. So if you're on, I set set digit. The zeros place, set you to be 1. Oh man, then I have to sleep 1. I don't have enough room for more than half of this, so we have to do 2 chips to listen to the P0 port twice. But I wonder if we can get away with one of these reversed. So here we have, okay, so we didn't know which one is coming out, and it's asynchronous now, and now they're exports. so I can wait. I can sleep on this. So now we can do these things. I might need the code space though. Like if we do something like that. I can hear they'll be snoring a little bit, which is super cute. Okay, so I guess the first thing to check would be the, I guess we'll do the bottoms because it comes bottoms up, right? So if we grab you out, you are gonna be, I think, so sleep X0, X0 to ACC, test if equal to, just want to know if you're on, right? If ACC is 100, you won't be 100, you'll be 110, won't you? Oh, I need to sleep too. Oh, because it's always sending something out, isn't it? This is always sending. Oh, okay. So I can't sleep X0. All right. So we have. I want to move X0. I wonder if I can test what it is on that same thing. So test equal, this won't work because I have to extract I have to move it. So move X0 to ACC. I need GT. This is the 2, I think. Let's see if it's the top one, 100. So test if equal ACC 1. So if you're equal to 1, then the button has been pressed. Otherwise, jump to end. We're just going to sleep 1 and then start over again. Otherwise, if we haven't ended, then I want to start grabbing the next 3. And then we set this in DAT. So I guess here is that we have to just immediately move 0 to ACC to reset that. And now I need to do a loop of 3. But I can't, I can do, we have to move 3 to that. Oh, but I can't sub 1. Oh, so I can't do a loop like this. That's not gonna work. Okay, so we reset the ACC. I would need to grab the first value out of here, which is going to be this one. Oh, but I already had that. Move 0 to... Okay, yeah, so this first one. So I don't want to move 0 to ACC. We have that. Oh, but I lost. Okay, so hold on. ACC did that, so I don't lose it. Get the second digit, test to see if it's 1. Okay, the button's on. I wonder if I want to test with a different chip to see if the button's on, and then I could just send something to wake the chips up and then start reading. I bet that would make more sense, and I think I have room for this. Unfortunately, not quite there. But I can put you here. And I don't care about the values that you read, I just care that you wake up from it, which is going to be fine. So here, okay, here we're going to move X0 to ACC. Oh, but then, okay, I need you. Okay, so move 0 to XCC, digit get 2, test if equal to ACC 1. If you're not, jump to end, sleep 1. If you are, hey, we're going. So time to move anything. Can I move null to X3? And that will wake everybody up. It is like nothing to go. And then we sleep and do it all over again. When we wake up, I want to just start reading from X1, right? So I want to move X1 to ACC. I have to isolate it, so we're going to digit get 1. So if you're on, I want to wow, this is gonna suck. So I have to do this multiple times, but like the digit set changes each time. Oh, I don't have the room for it. I wish that I could digit set on that. I can't. Can I? Wait, can I do that with data? No, I can't. Okay. It has to be an ACC. So I'm trying to use too many ACC things at once. Okay, so see, I feel like this is now hurting me more than it's helping. Like, okay, so if we just have the button come out. So let's reset. Oh, you have to be a, you're right. You have to be a P. And then we're gonna set your go time, your go time. Now, can I do something like this? Well, I wonder if I can read from it from both, or if that's going to be a terrible idea. Okay, so we're going to move P0 to ACC. We're going to test if equal to ACC is 100. If you are 100, we are going to just send a message to X1, hey, we're going, right? So move 100 to X1. And then we can sleep one because we're done. And actually, we don't have to do anything until like at least 6 turns, like 6 things pass. Okay, for you, we've now received this. we're going to sleep X on X0. As soon as we wake up, you are going to immediately go in and start doing your thing. So I want to test if equal P0 is 100, which means that I want to reset, move 0 to ACC. If you're 100, I want to D set 0 to be 1. We're gonna sleep 1. Test if equal P0 to 100. You are DST 1 to 1. Sleep 1. Test if equal P0 is 100. DST 2 is 1. Sleep 1. I don't actually know if I need to sleep 1 there, but I then want to throw you into here. So we're going to move ACC to X2. You never ran. You never woke up. Why didn't you wake up? Why are... Oh, let's not sleep 6. Let's sleep 1. There we go. Okay. Oh, part not sleeping. Blocks on right. Move 100 to X1. Because I need to do something with it. I can't just... So move X0 to null. I don't care about you. Ooh, okay. That's being set up. Okay, so what if I now... Sleep X, X0, move X0 to null. I then want to sleep... Okay, I want to skip the first 3, right? So we're going to sleep 3. And then we can start doing test if equal P0 is 100. And if you are, GST 0 is 1, sleep 1. Equal P0 is 100, DST 1 is 1. Sleep 1. DST. Nope. Sleep equal. P0 is 100. DST 2 1. Sleep 1. Move ACC to X2. Oh, because one of you moved to null. Okay, so I only need one to move to null, not both. Okay, well, I'm setting things. It's the wrong things, but I'm setting. I have to move. Okay, so this gets 0 to move to ACC. After I wake up, let's also move 0 to ACC to reset you. It's the wrong things, but things are happening, which is good. Oh, why are you already setting stuff out? Oh, I need to wait. So hold on, sleep at least 3 more. Okay, the first one works now. Okay. So I sent you off and I wanted the first two on, and then I don't want to sleep one more time here. Okay, I think we got it. Splendid! How wonderful that such a device was created right here in China, where it all began. I'll probably even use this oracle myself as Xiaomei and I approach our wedding day. David is more Chinese than even a Chinese person. Okay. Well, hey, I'm glad we got like at least one puzzle done today, although we had to skip the control router. Okay, more Shenzhen days from Tilly. The electronics wet market is as sexy as it sounds. One thing I always tell people who come through Shenzhen for various reasons is to check out the electronic parts market in the Huaquang area. Is that how to pronounce it? I don't think I'd pronounce that right. It's insane and super interesting, even if you aren't here for electronics at all. Imagine your traditional Chinese wet market, bustling with activity, hundreds of stalls bursting with everything you can imagine, except everything being exchanged is electronics parts. Substitute the smell of fresh solder for frying oil. Think of digital trash littering the streets instead of food scraps. And it's not just a few parts, okay? But every type of every part. Like there are entire markets dedicated to insanely specific things like batteries, say, or LEDs. It's a continuous white-hot exchange of every manner of everything electronic, of anything electronic. And craziest of all, these guys represent manufacturers who are also right here. You could find a part from a dude and ask him if he can supply your company with 1 million of them later the same day, and they could. It could happen. I try to convey the scale of that kind of thing to people who haven't seen it, and it just doesn't come across, you know? Oh, a market, that's nice, is what people would say, especially back when I lived in Vancouver. They were probably picturing something like the local ham radio swap meet where they were dragged to when they were 5. They didn't get it. You won't get it either unless you see it. Go see it. Yours, Tilly. I think I've heard about something like that before, but I don't remember anymore. It was a long time ago. All right, next puzzle. Let's see how far we can get with this. Precision food scale. Okay, so David's bringing this up. Are you aware of the system of precise dieting? This trend, which originated right here in China, has people across the globe measuring down to the milligram what they put in their bodies based on the ancient principles of yin and yang. Actually, my fiancée, Xiaomei, and I have been trying it for the past month or so ourselves. It really boosts our stamina. I believe a portable food scale aimed at the precise dieting community would do quite well. Okay. Simple. We can include a tare function to zero the display value when the power button is pressed. And of course, Carl is asking, stamina? Okay, so we're definitely onto display things now. But okay, so precision food scale. Weight is a simple input connected to an electromechanical scale calibrated for grams. Button is a simple input connected to a power 0 button. Display is an X-bus display output corresponding to a numeric LCD screen. The scale is initially off, but can be turned on by pressing a button. While the scale is on, the display should be updated with the measured weight. If the display is showing a value other than 0 when a button is pushed, the scale should zero itself so that the current display weight is 0. If the display is showing a value of 0 when a button is pushed, the scale should turn off and clear the display by sending it the value 99. Oh, okay. Oh, okay. So we have to, this is the one that's going to be probably the hardest, is like detecting if, like, we have to keep track of state. Okay, so if this button is pressed on, we're on. So if I'm gonna have state, that sounds like this thing here. And these are P. Okay, so we're gonna have to do P0 to ACC. No, we can just test it, right? So we can test equal P0. If you're 100, move 100 to that to show like we're on, right? I don't know what to do with this information yet, but okay, we can do that. I should probably move you out like this so I can have a little bit more room. So now that I know that we're going to be on, and we're going to have to also check to see, okay, oh, if the power, okay. It's a power 0 off button. Okay, so it's an on, 0 off button. So there's three things it can do. So I don't actually know if I want to put this here. So we start with nothing on here. So let's imagine that I have something like you. So if we initialize by move, we're gonna move maybe into ACC or data. Move -99 to ACC. And we're going to start by moving ACC to X3 and sleep 1. And so that sets it to be blank. The power button gets turned on. And so when the power button gets turned on, I don't actually care about this coming in. I just need to know that it was pressed. So when you're pressed, I have to update that. The move ACC is probably going to be the last thing we do. So at this point, I want to I can't sleep on this, can I? Because like we're gonna be constantly sending out whatever is in here. So I don't want to use X1. I want to use the simple ports. We can test if equal P0 is 100. If you're 100, we then need to check which state we're in. So if we're less than 0, okay, so if we're greater than 0, we zero it out, right? So like test equals to that. Okay, so now I'm gonna test. What if I can just jump to reset, like jump to power? Okay, so I'm going to test if equal to okay, so test greater than ACC and 0. So if you're greater than 0, I want to I guess it's no, because okay, so if we're equal to 0, we turn off. If we're less than 0, we turn on. And if we're greater than 0, we reset to 0. So yeah, okay, so greater than. Yeah, I actually don't know if that's gonna work. I probably don't want to jump to power. I probably don't have the room for it anyways. I then test greater than ACC and 0. So if you're greater than 0, I want to set move 0 to ACC. I've lost you now, which is interesting. Because if you're equal to 0, we turn off. So move 999 to ACC. I don't like this. I feel like I should TIS it where I move it out to something else that does the processing and sends it back. I like that. That could be an X chip. For you, I wonder if we're gonna have to do something like this, where we're reading from both of these. Wait, no, that's a bad idea. Okay. So if I do this, okay, test if equal is P0 100. Okay, so the power button was pressed. I want to move ACC to X0. And then I want to sleep on X1 and wait for this to finish doing its thing. I wonder if I can just move. It's like then move x1 to ACC. So I basically just reset whatever this is in here. And now you do this thing. So you're gonna sleep x on x3. Move x3 to ACC. And then we can, okay, test greater than ACC 0. Okay, so if you're greater than 0, I want to move 0 to x2. Test equal to ACC 0. Move negative 999. x2. Test less than ACC 0. Move 0 to x2. Okay. So then theoretically I have this back and I know what I'm doing. So if as long as the power is on, I want to send whatever is in P1 out x3. Right? No, I want to set it to ACC. So test greater than ACC is -1. Move P1 to ACC. Move ACC to x3. Sleep 1. So if I do that, you're not connected. What? You're going to P1. Oh, interesting. Okay, so I'm off by a little bit, but some of it, after it turns on, it kind of works, except for turning off. Turning off doesn't work either. Oh, interesting. Okay, so my sleep. Oh, that's very interesting. Okay, so I want to, I'm off by 1 here. Is that what's gonna happen? I was off by 1. So I need to do this before I sleep. I need to change the order I do these things around. So maybe I'm constantly moving the weight into ACC. No, I can't constantly move into wait in ACC. I can only do that if we're on, right? So I take you 3 for the power. And before I move you out, we do your check here. Oh no, everything's off. I was so close. Like we're so close, but I'm off by 1 instruction. Is there there was a no op, right? Yeah, there's a knob. Oh, I want to do the knob up here. Ooh, what was that? Okay, so I had the 0 here, correct? Oh, because I never do anything with you, so you just stay there. Okay, so I want to sleep, move 100 to sleep 1, and then move 0 to P1. Oh, we almost got it. Okay, so let's see. We turned on, we weighed some stuff, we reset to 0, we turned off, we turned on, we weighed some stuff, and then the reset to 0 didn't work. I'm guessing it's because the knob. Do I not need that now that I reset you? No, I definitely need some kind of knob. Or at least I need to somehow synchronize when these are running. When would I want to pull from? Well, okay. So the first thing I'm doing here is I'm just saying, if you're on, move you into ACC, so you store our latest, like what we are. And then we test the power. And then we go. When I had the knob here, it surprisingly worked fairly well, especially for the first few cycles, and then it doesn't work. For this one. So where we are, okay, so we're checking to see, are we greater than -1? We are. Move P1 to ACC. So get the new weight. We're good, go. New operation. Do I not want to sleep an extra time here? No, I definitely do want to sleep an extra time there. Okay, so if we are it's like I'm a full loop off. So like I don't think having multiple knops is gonna help us at all. Like I could just throw that in there for fun, but I don't think that's gonna do anything for us. Because we still have the same problem of this not sending out at the right time. We're delayed from there. And like, it doesn't matter if I put a whole bunch of knops. It's still gonna be the same issue. Which is, at this point in time, we're at the wrong location in this loop here. And the power isn't being set out. Or rather, we're not reading from the power. So at this point in time here, we're testing, okay, so are we greater than this? We're still assuming we're good to go here. You are... Why are you here in this loop? This is the beginning. Shouldn't you be up here? Okay, now I'm actually curious. Okay, what about there? Okay, so here we're at the top. I don't think I want to do 2 sleep ones. Do I only want to sleep one if I also sent this out? I don't think I need more than 1 knot. Ooh, I had it 0 and then turned it off. Okay, so we're back to the top here, which is a good sign, and we're at the top here. So greater than that, so therefore we're going to send this out. So move this into there, that's 32. You are 100, so move 100 to P1. We have the no operation. Test if equal to P0 is 100. You are, move ACC to X0. So you do your thing. Okay, so that goes out there like that. We're now going to sleep one here. And we're still sleeping there. We turn the power off because we're no longer doing the thing. Hold on, getting some text messages from people I'm gonna hang out later. Okay, cool. So we still have 32 in here as the weight coming in. Is the power on? The power is not on. So I move ACC out. Oh. Oh, wait. So the first thing goes through, we set 0 out. 0 is ACC. If I set you greater, wait a second. I'm questioning the test data now. Okay, so I set you to 0. Do I need to sleep more than 1? When I reset, yeah, look at this. Okay, so I'm resetting to 0 and then I eventually go to 28. Oh, so I'm supposed to forget what you are. I'm supposed to forget what that is because I'm resetting it to 0. Oh, wow, wait a second. 32. I'm not following how scales work. When I reset to 0, what it really means is that I should be subtracting what this is, not setting it to 0, 0. Which that's going to be tough. Because it's not always that we do that. Oh no. It's a logic math thing. When do I sub by this, and then how do I know that I've already subtracted? It's like, okay, to get to 0, what I need to do is sub 32. And then because like this is going to be 60 is coming on the weight, but I need to take 60 and subtract 32 from it. Or rather, Yes, this kind of helps. But I don't know what the previous state was. It's like, I need to keep in dat, I need to keep the state of like, oh, we're on, we're off. Which I guess we have this in ACC, but we don't know the... I mean, okay, so if we start with -999 in both of these. So -999 is off. I wonder if I should just use like a message, like we have move -1 to dat is off. And then this logic is going to have to change. So I want to do something like -1 is off, 1 is on, 0 is tear, or whatever it's called. Then I want to check to see what is dat, right? So look, let's assume dat exists. So test greater than, okay, so test if we're off, we don't, I think I need to just reset all of you. Okay, so if we're, I have to change the state first, and then I can send stuff out. So the first thing we're listening for is the power, probably. So test if equal to P0 is 100. If you're 100, the power button has been pressed. I want to we have to check to see what you are, don't we? Because if you're -1, we turn you on. If we're 1, we turn you off. Sorry, if we're 1, we... Oh, yeah, okay. I might want to do the cross trace for this power check thing. It's like, let's say I don't have anything out. We're not going to sub. I don't sub dat from, oh, we're going to sub dat from ACC no matter what. So this is just starts out at 0. Okay, so if you're 100, now I start needing to check. If ACC is -999, we set so yeah, I could definitely see moving this out again and doing this. So we move ACC to X0. I mean, so if I do that, that sort of does the same thing where I've reset ACC to whatever this is, but I also need to check to see if before I even do that, I have to check to see if ACC is greater than 1, because if it is, I mean, we could also do two things here, right? I could say move x1 and then move x1 to dat. I don't know if I have room in here, but we have enough room on the board for a bigger chip. Okay, so we're sleeping on this. We move you into ACC. We test if you're greater than 0. If you're greater than 0, yeah, so let's do a bigger chip. Okay, so SLX X3. Move X3 to ACC. And then also move the exact same thing to DAT, right? So move ACC to DAT to store that away. I want to test now. Okay, so the power button has been pressed. So test greater than ACC and 0. So if you're greater than 0, we are tearing out, which means I want to move 0 for x2 for that. Okay, and then I also, at the very end, I'm going to move that to x2. So that's good there. Target equal to ACC 0. So if you're equal to 0, we're turning off. So move negative 999 to x2, move 0 to that. Test less than ACC 0, 0. Now we're turning on. So to move 0 to x2, move 0 to dat. And then the dat gets sent out as the second thing every time. So now I have you in here. So that tests the power. Then I want to move I want to move P1 to ACC on a sub dat, move ACC to X3. Does that work? Oh, and then sleep. Surprisingly works pretty well, except for the zeros and the nulls. Okay, so what happens to begin with? ACC gets set to -999. We test to see if power is on. It's not on. we move P1 to ACC. Oh, but you're not on. Which then sets that to 0. That's the problem. I cannot do that unless, so we have to test greater than, ACC is -1. If it is, move P1 to ACC, then we subdat. Okay, interesting. Scott, hello, how are you doing today? Now this, okay, so this one failed. Okay, so we're at the top of each of these. The power button gets pressed on. But we've already tested this. That's the problem. That's the problem. It's like, it's back to this problem again where I need to do this at the bottom. Like, I almost need to do that. Oh, we got so close. We got so close. It even works with like tearing it out to here. So, oh, because you're supposed to display a -32. Okay. There's no such thing as not equal, right? So I can do target equals ACC -999. And we can just switch you to that. Did we get it? I think we got it. Yes! 2 puzzles today we got. Although we did completely fail with one of them, but that's a different thing. Splendid work. This truly is the essence of or whatever they called it to begin with. Oh, yin something. Precise dieting? This is truly the essence of precise dieting in electronic form, and another great example of the confluence of ancient wisdom and modern technology. I am excited not only to introduce this product to the world, but also for, I forgot his fiance's name, and I to use it ourselves. Whoops, sorry, I know not everybody here can read characters. Zhao Mei is my girlfriend. Of course, he keeps on, he is like, he's one of those people who like just name drops his girlfriend constantly, which is always annoying. Oh, Carl, what is this? Anyone ever heard of the PGA 33X6? A pushy stall vendor nearly stuffed these in my pockets as I was walking through Huaquangbang? That is not the right pronunciation. Sorry about that. Last night. No idea what he was saying. Have some naff undocumented chips, I suppose. Well, I guess we have a bunch of them now, if anyone can figure out how to make use of it. Cool. My brain is starting to hurt already, and it's only 11. I don't know how much longer I can go. We could try starting with this one, but then we'll see. Okay, so Wu says, We've partnered with a major financial services company to create a cryptocurrency deposit terminal for people concerned about turbulence in a financial system. It should do especially well in regions where people are worried their government-issued currencies may be devalued soon. The terminal reads an account number from a cheap magnetic stripe card, accepts a cash deposit, and sends the information to the bank over the internet. Because nearly all of the money is flowing in a single direction, we just need to have it handle deposits. Okay, I don't know much about cryptocurrency, but nothing about this sounds like cryptocurrency. Isn't like cryptocurrency supposed to be like that we like send a cryptographic like hash or something to, oh no, we have to add it to like the chain and like have a bunch of people verify it. Like literally everything about this sounds like it's just a normal deposit. It's just a normal ATM. They're not doing anything crypto with it. Card reader is a non-blocking XBus input connected to a magnetic card reader. Okay. Cash 20, Cash 50, and Cash 100 are simple inputs connected to a mechanism that accepts and detects yuan. Network is an XBus connected output connected to a network interface. The user initializes a transaction by inserting their account card indicated by an 8-digit data packet from card reader. The user then inserts money as indicated by the cash signals, which we have to do, right? No. We don't have to do that at all. The user finalizes a transaction by ejecting their account card, indicated by a value of -1 for the card reader. When a transaction is finished, the 8-digit account number and the total amount of the deposit should be transmitted over the network to the bank. Okay, so card reader is just going to be getting lots of stuff like -999, but then all in one go we get all this. So we get the card itself, and then we have to wait a bunch of time for the -1 as people put in cash. Okay, got that. Now, so my immediate thought, these are these new chips. The fact that they mention this makes me think that this is gonna be essential for this puzzle, which they also said was undocumented. 33x6. No, it's documented. It's just documented in Chinese. Oh, that was it? Cool. Oh, you don't have any, let's see. Okay, I think that's starting to work. Sometimes we encounter situations that cannot be solved with conventional components or normal means. For this reason, we developed the PGA 33X6, which has a flexible and powerful logic structure that can enhance any installation. The fact that this is like perfect English coming out of the translation makes me think that they wrote it in English and then just ran it through this exact translator. The operating capabilities of the device. Highlights. 3 simple buffered input pin, 3 simple buffered output pin, transition zone multiplication column, set reset flip-flop with feedback and direct output capabilities, has been organized with the sum of products on-off configuration to arbitrarily map inputs to outputs, ability to replace hundreds of discrete logic gates, not suitable for low power applications. Okay, so that doesn't really tell me how to use it. Multiply the train. I'm guessing these are inputs and outputs. Addition row. Okay, so this section is multiplication. This section is addition. Yeah, enter, and then this is probably exit. Oh, okay, close enough. So interesting, multiplication and then addition down here. So now this first one, okay, so I get 2 100s in here. So if I take 2 100s in here, I don't want to multiply you at all. Oh, that's interesting. The rules of like clicking these. I don't know what those are. What I want to do is I want to like add these together if possible. I don't know if that's a thing. Let's see, you're going into data. Okay, if I just send you okay, 100 goes in there. Ooh, so that goes down to you. Why does that go down to the bottom row? Is it just oscillating? So if I click you, data is 1 now. Okay. Ooh, and I sent 100 out. So none of that has changed. It still sends, oh, that sends a 100 out forever. That's not necessarily what I want. Yeah, that continues going regardless of that. Okay, so if I send you all in, I don't really get where it's going down with that. Like, is it multiplication on the top where I want to multiply it and then I add it? Something like that. Okay, that didn't add into data, so data's line coming in is from down here, right? Oh, so that just goes out to here. Okay, these are OR gates. These are OR gates, right? So this, when it's on, it flips to here. So then I want you to go, okay, so you switch to on, and I want to send you down. To there to go up to data. I don't know what the S and the R stand for. Set, read, and then data is going out something else. Oh, you turned on, okay. Right, okay, you turned on right away when I did that. Oh, why is data 1 now? Okay, that's not how to use this. Now if if I set all of them, so these are multiplication, it says it's multiplication. So here, if you come in here, I don't know what these two lines are for. Like, these are the inputs, and those are ORs, right? So when it's powered on, it's the bottom one, and when it's off, it's the top one. So I want, just for the bottom one, I want to set those to be on. I don't know which ones of these I want to be setting to on. That data is only set to 1. That turns data to 0. Okay, now if I turn you, okay, you're not on at all. If I like set your entire line, that doesn't do anything. I mean, so what if I don't want anyone in the same bus there, but then connecting in, I want to add you all to set? That didn't add together. That didn't do anything. I'm guessing that the R is read, but it could be anything. There's also this thing where, like, I can set you all on or off. And I don't know what these mean here. I mean, so you're setting on the power in the middle, but that's because I have U set on. Your AND gates, right? This is or an AND. Oh, I don't remember. I don't remember slash like. I remember like studying these back in college, but that was a long time ago. I don't remember what any of the symbols really mean. Yeah, so I have no idea how to do this unless I looked it up, of like how this thing actually works. Which obviously is cheating because they don't want us to do that. Otherwise they would have given us more information in the documentation. So I don't know about that. I'm betting though that if you knew how that worked, you can set it up pretty easily. And then everything would just work, like with like one chip or something like that. And the rest of it is going to be something like this. Okay, so I have to wait for this -1. So I have to read into the card reader. So we have to Oh, I probably need to just send this into a memory. That's probably what it is. These are always the same digits, right? I think so. So if I take U, I can just throw you into memory here. Okay, so there's 3 choices here. It's -999, it's -1, which is the end, or it's part of the thing. So if it's test equal to ACC, if you're -999, I don't care. We're going to jump to start. Okay, so then test equal ACC -1. Jump to end. Otherwise, I need to loop through 8 times, which I don't have room for in here. So I need a bigger one. Okay, so in here, then I need to move 8 to ACC. Now, if we just got finished with the loop, we never get the -1 immediately afterwards here. So we can just jump back to start again, like that. And with end, I want to probably move, it doesn't really matter what it is, ACC to X2. Just to let them know, like, hey, we're done. Oh, okay, so I can't SLX. We have to just move you. So we just move X1 to ACC. You're never sleeping here. Okay, so move. Okay, so we move X1 to ACC. Oh, why did I do this twice? I need to do it twice. Okay, before I jump to start, I have to sleep. So I have to, okay, I got 0, 0. Okay, so we lose that one, so I want to six the accumulator. I wonder if we should do like another end where like I'm actually listening elsewhere for the end. That feels safer. I don't think this is a, I don't know if, this looks like I'm setting myself up for not happy times. Okay, move X1 to ACC, test if equal to ACC -999. If you are -999, sleep 1 and then go back to start. Test equal of ACC is, okay, so what if I don't do that? Then it's, okay, oh, I guess I need a test to see if you're, test if greater than -1. If you're not, we're sleeping. If you greater than shoot. Okay, greater than -1, yeah. So like it actually has values. So this is gonna work. So okay, so if AC is greater than -1, sleep 1 Oh, okay, if you're not greater than -1, sleep 1, jump back to start again. Otherwise, move 6 into ACC. I lost the ACC, so I have to move ACC first into X3. Then I move 6 into ACC. I then move, okay, move these down, sub 1. If you're equal to 0, jump back to loop, do that. Sleep 1, jump to start. You never get to end. Okay, so we got 0, 0, 0, 7, 4, 3, 9. Okay, so off by 1. This is 7 here. Okay, there we go. So our writer is here, but our reader is here, which is fine. I'm not actually seeing the values come out of here, which is kind of sad. But okay, so our X bus, which actually any of these work, so we should be able to read it from any of these. I have to use a small one unless I want. So move X0 to ACC. Okay, so we can test to see which one is what, right? So if I just do that, we should be able to see. Yeah, so you're 10 because cache 50 came out. You're 1 because cache 20 came in. And you're 100 because a cache 100 came in. So if I do something like this, I could I'm probably gonna have to listen to the end here, but then also listen to you. So move you to ACC, and then I want to test to see, okay, so if only one at a time, so this is gonna be fine, right? So test equal to, if you're 100, we got, what was that? It was, okay, so it's 1, 10, 100. Let's test equal ACC to 1. So if you're 1, I want to move 1 to X2. Test equal ACC 10. Move 20 to X2. ACC 100. Move 100 to X2. Okay, so that moves all those out, and then we reset. And so all I'm doing is I'm just converting these into actual values. Okay, so we start with 0 in our ACC, right? So I just want to SLX X1 add X1 to ACC. And so this should just be consistently adding in. So after this first one, we have 221. Let's see, what? 250, 70. This should be 270. Because I didn't do this right. Okay, so if you're 1, you didn't send 10 out, you sent 20 out. then you sent 50, and then you sent 100. You still have 201. Oh, because, okay, so hold on. You're 20. Okay, so if you're 1, you send out a 20. If you're a 10, you sent out 50. If you're a 100, you send out 100. 270. There you go. Okay, so now we have our proper amount of money that we have here. If we receive a 0, sorry, if we receive an information from our little end tracker, which is going to be here. I can't see this, can I? Because if I try to move you in, you're not going to read it. Can I test what you are equal to instead of moving? So test greater than test greater than -1 or x1 -1. Then that could be 8. And then here we're going to do test equal to x0 -1. If you're -1, I want to move. Doesn't really matter, right? Like to x2, let's say. Or we just leave 1. Okay, so we're adding this along. If we ever receive the end, I want to send that out. So then test equal x0 100. Okay, so if you're 100, I want to move ACC to x3. And I want to move 0 to ACC. So that resets. I need to test equal x0. I need to throw this away, don't I? So move x0 null. You need to be a simple part for this to work. You got something in. No, wait a second. You should not have gotten something in. Okay, so that's writing all down there. Wait, how did you get here? Why did you send a message? A -1 was never received. I'm really confused. Why did we receive a -1? Oh, because I'm now waiting on that part here. This needs to be a P part, like a simple port. Which means you need to be a simple port like this. Okay, so we're gonna move X0 to ACC, test if equal to ACC. Oh, we don't have to move because we're not taking ownership of it. We're just viewing the wire. So test equal to X0 is -1. If it is, we're gonna move 100 to P1, sleep 1, and then no matter what, we're gonna move 0 to P1, sleep 1. And then we start over again. You are going to I have to be checking this every tick, don't I? I can't do the SLX. At least I don't think I can do the XLS. So if I just test if equal X0 oh, actually just move this, right? Yeah, because if I'm sending nothing out, so then this should be a P as well. Okay. Now it's hard for me to think and concentrate. So that's usually a sign once I say it like 3 or 4 times that it's like, okay, I think I better call it. Now we have been streaming for almost 4 hours, which I think for like these type of games, at least like the hard puzzle games, are about my limit before I just start mentally not able to handle it anymore. So I think what I'm going to do is we're going to call it for a day, and then we will come back to it next week and then see if we can get any further with this. I feel like this is not that hard of a puzzle. It's just my brain isn't working right now. So I think that if I switch this over to a standard one, so the MC4000 instead of the MC4000X, then I can convert this into the P that's sending out. So it's basically we're sending out a 0 or a value, and so I just read that value once and then it's back to zeros again, and I can just check that here and accumulate it up. I think that would be fine. I could even at that point in time write it into here once this is done, and then that sends another final message to then read everything out into the network. I think that's the way to do it. I just don't have the patience in me to do it right now. So that being said, I am done for the weekend streams. Let's see, so I have some like meetings coming on later today. So one of the meetings is going to be helping determine whether or not like I'm going to be super busy in the nearby future. So I'll let you all know what comes from that, or at least early second. For the course, for the Docker course, we finished setting everything up for it. I need to get the descriptions into the LMS for all the articles, and I have that as a to-do list for myself before Monday. So to basically get everything set up so I can start selling it on Monday, and then we get to decide what to do on Monday. Probably announcements, some random videos, maybe a new project. I'm not sure. Tuesdays is going to remain LMS sort of time, where I'm going to work on updating the LMS on Tuesdays with new features, even though like we're past the bare minimum needed for that. And I think that's it. I think that's it for all the sort of like announcements, knowledge right now. I have also been playing with a, I got a new mic a while back, and by new I mean new to me. It's a used mic that a previous company I was working at that no longer exists had. And so I have that out here. I have it actually set up, but I'm using the old mic right now because I don't know how this is going to sound. So we'll probably play around with that a little bit more later, and then like on Monday we can test it out, give it the ropes. That's not the right saying. Put it on the ropes, something like that. Clearly brain is not working. So with that, I hope that you all have a great rest of your day. Have a great rest of your week. I'll see you all online and next time on Monday. So with that, have a good one and see you then. Bye.